Hi everyone, let's do Leetcode 238, product of array except self. So we're given an integer array as input. We want to return as answer another array such that each position in this answer array is equal to the product of all the elements in the input array except the number itself. We can better understand this if we look at an example. So in this case, we have this input array and this is the output array. So let's look at how we got this output 24. We want the product of all the other elements in the input array except the position we're actually evaluating. We want the product of 2 times 3 times 4, which is actually 24, and we got 24 here. How did we get 12? So 12 is at position 2. We want the product of all these elements here, 1 times 3 times 4, it's actually 12. How did we get 8? So 8 is in position 3. Position 3 in input array is this one. So we want the product of 4 times 2 times 1, which is 8. And the same thing for 6. One constraint is that we cannot use the division operation because this would make this problem really easy. We could just take the total product, in this case 24, and then for each position we can take 24 divided by the number at that position. So 24 divided by 1, 24. 24 divided by 2, it would give us 12. 24 divided by 3, it would give us 8. And 24 divided by 4, it would give us 6, but we can't do that. So let's look at another way of doing this. Okay, let's look at this possible linear time solution. We know that for each position, we want to have prefix and a postfix. So let's take 2 as an example. We know that the output product here is going to be the value that comes before times the product of the values that come after. So in this case, it's going to be 12 times 1. In this case, we're going to then multiply these two together and put the result in the output array. What we could do is we could actually calculate the prefix for each position. So for example, we could calculate the prefix that comes here, the prefix that comes here, and so on. So let's actually do it. Let's start calculating the prefix. For this position, we can assume that it's 1. We know that any number multiplied by 1 gives us 1. Now we want the prefix for 2. The prefix of 2 is 1 because we just have this element. We want the prefix for the number 3 is going to be 2 times 1. We want the prefix for 4. So we are going to do 3 times the number that comes before, which is 2. So in this case 6. And same here, 4 times 6, 24. So this is the prefix over here. Same thing for the postfix. So we are going to assume there is a number that comes after, which is 1. So this is going to be 4 times 1, 4. We want the postfix for 4, which in this case is going to be 3 times 4, it's 12. Here is 2 times 12, 24. And here is 1 times 24, which is 24 again. In order to get the output value now, we can just multiply these elements. So now it's going to be way easier to find the output. So let's say we want the output for the first position. This is going to be 24 times the prefix of 1, which in this case is 1. For 2, we want the prefix of 2, which is 1, and the postfix, which is 12. This is 12 times 1, 12. For 3, we want the prefix of 3, which in this case is 2, and want the postfix, which is 4. So 2 times 4, 8. We reach 4. We want the prefix of 4, which is 6, times the postfix of 4, which in this case is this one. So the output is 6. And we can verify that this is the same as our desired output. The time complexity of this solution is actually O of 1, and the memory complexity is O of 1 as well. There is actually a simpler way of doing this where we can avoid calculating prefix and postfix using extra memory. So let's quickly look into that. So another way of doing this problem is to actually store the prefixes already in the output array, so we can avoid using extra memory. For example, the prefix for 2 will be stored here, the prefix for number 3 will be stored here, the prefix for 4 will be stored here. We can assume we have an external variable which is going to contain the first prefix, which is going to be 1, which will be stored here. And then we can do a second pass starting from the end, calculating the postfix and multiplying the postfix by the prefixes that are already in this output array. And once we have done the second pass, at the end the output array is going to contain the desired result. So let's look how this is going to look like. So we are going to have a variable that is going to store our prefix, and the initial value is going to be 1. So let's take this we want the prefix for this position. In this case it's going to be whatever is in our variable, so it's going to be 1. Now we're going to update our prefix doing the number times the prefix, so in this case it's still going to be 1. Now we want the prefix for 2. In this case we're going to take the prefix, which is 1. Now we want to update our prefix variable, so we are going to do 2 times 1, which is 2. Now we want the prefix for number 3. In this case it's 2, and now we want to update our prefix. So we're going to do 3 times the prefix, which is going to be 6. Now we're going to put the 6 here, and we can stop because we have reached the end. In the second pass we want to do the same thing. So we're going to have a postfix variable, which is going to again start at 1. We want to take the postfix for 4, which in this case is 1, multiplied by the prefix, which is already there, and the output now is going to be 6. We want to update our postfix, so we're going to do 4 times 1, which is 4. We are going to take our postfix and multiply it by whatever the prefix was for that position, so we're going to do 4 times 2 and have 8. Now we want to update the postfix, so we're going to do 3 times 4, which is going to give us 12. We're going to take the postfix, multiply by the prefix, which is 1 in this case, so it's going to give us 12. Now we're going to take the number that we have just updated the position of, which is 2, multiplied by the postfix, so we're going to have 24, and we're going to do 24 times 1, and we actually now got our output array without using any extra memory, and this is the result we wanted. So the time complexity of this solution is still O of 1, and the memory complexity, it's constant memory, so a big O of 1. Okay, let's write some code now. So the first thing, I'm going to create the output array, which is going to be our result. So I'm going to initialize it with the same number of elements as the input array nums. Next thing, we need a prefix variable, which is going to start at 1. And we're going to iterate through the input array. So what we want to do is, we want the position I of the result array to be equal to the current prefix. And then we want to update the prefix. So prefix times the input number at position I. This way we have filled the result array with all the prefixes. Now we want to calculate the postfixes and actually fill our result array. So we need a variable. Again, we're going to initialize at 1. And we need a for loop that is going to start from the end and is going to go up until 0 and is going to decrement by 1 each time. So we want the result at position I to be equal to whatever is already in the result, which is the prefix, times the postfix so far, and now we want to update our postfix. We're just going to multiply by nums of I. Once we have finished the second for, we can simply return our result array. Let's see if this works. As you can see, it does work. Please like and subscribe if you found this video useful. Thank you.